Hi, in this video, you shall learn how to draw a simple photonic circuit in our GUI and perform circuit simulations on it. Besides evaluating the nominal response of the circuit, we shall also perform a corner analysis. You can create a circuit schematic in our GUI environment IPKISS Canvas. To design a photonic circuit and analyze its behavior before considering a physical implementation, standard components from the generic devices library can be assembled into a schematic. You can drag and drop these components onto the canvas, and you can connect them together by clicking on the respective ports. By right-clicking on a component and selecting the Properties button, you can modify the behavioral properties of a component, such as the cross-coupling ratio of a directional coupler, or the effective index and length of a waveguide. With this, you can specify connections between different components and define a circuit schematic. I have implemented an MZI lattice filter. This is created by cascading multiple directional couplers which are connected together with different waveguide delays. To run a simulation of the circuit, you can drag and drop the S-matrix sweep codelet from the generic devices tab. This codelet allows you to simulate a circuit and get the frequency response. You can configure the wavelength range within the properties and the number of points within the wavelength range which you want to simulate. And you can run a simulation by pressing the play button. Since fabrication of photonic components is not perfectly reproducible, variations are expected in the responses of different components. The impact of performance variations can be studied in a corner analysis. This can be done by dragging and dropping a custom codelet named corner analysis onto the canvas and pressing the play button. In this case, we analyze the circuit performance when variations are introduced in the cross-coupling ratio of the directional couplers. Such an analysis would assist with an initial feasibility study before a physical implementation of the circuit is considered.